so we recently learned about matrices and all the operations that you can do with matrices, and they work as a great way to organize information. They actually have other properties that are handy as well. And today we're going to talk about the determinant of a matrix. And a determinant is just a single value, a number that can be calculated from a matrix that can be used to determine a variety of things. So this idea of a determinant, we're going to start by just finding the determinant, and then we'll do a few examples of where this can be handy. All right, now, the thing with a determinant, you can see that I'm going to look at 2 by 2s, and then I'm going to look at 3 by 3s, then I'm going to do some applications. Well, determinants can only be done on square matrices, so that's why we're only going to look at 2 by 2s and 3 by 3s. We're going to start with a 2 by 2, since that'll certainly be easier. And so the value of this determinant is a scalar value. So that just means it's a simple number. And it can be computed in a square matrix, has a variety of uses. Today we'll just learn how to compute it. That's not true. We're going to actually do some stuff with it. All right, so here's what a matrix looks like. It has these brackets around it. Now, the notation for a determinant is very similar, but has one key difference, is that it's not really a bracket, it's just a bar. Now, this might look like an absolute value. That's not what's going on. It's just a bar. You've got 4 numbers inside of here coming from your 2 by 2 matrix. So if you just see the bars, that's going to indicate, hey, you need to be finding the determinant. It's almost like if you had a square root symbol on it. It just tells you what to do. Another thing you might see is just this DET and whatever matrix letter is named. To find the determinant of A, which would be this, is actually a pretty quick little thing in a 2 by 2 matrix. So all we have to do is we take A times D, which is this, and I'm going to subtract B times C, which would go this direction. So you're kind of doing like these diagonal things. So to find the determinant of each matrix, the first thing I'm going to do is I'm going to multiply this direction. 3 times 2 is 6 minus, now I'm going to go the other direction, and I'm going to take -2 times -1, and that's 2. And 6 minus 2 is 4. And that's your solution. Okay, you try B on your own. All right, if you go this direction, you get 6, minus this direction, you get 6. Oh, you end up with a 0 for your determinant value. That actually isn't really a good thing. A lot of times that can be restrictive when your determinant is 0. Now we kind of do the same idea on 3 by 3s, but it's definitely amped up a lot. So you're going to start off and you're going to have this 3 by 3 matrix. And you can see the bars say, hey, find the determinant. All right, so what the first thing you're going to do is you're going to grab this first column right here and you're going to repeat it out here. Then you're going to take your second column and you're going to repeat it out here. So you end up with actually 5 columns. And then you're kind of doing the same thing. You're kind of doing this diagonals idea. And so that you have a lot more diagonals to do now. So you're going to do this diagonal and this diagonal and this diagonal. And what you're doing is you're multiplying these values together. Multiply, multiply. And then you're going to have these 3 numbers and you're going to add them up. And we're going to call that X. Then you're going to do the same thing. You're going to go up, up, up. You're multiplying as you go. And you're going to take these 3 numbers, you're going to add them together, and you're going to get Y. And then in the end, you're going to take X minus Y. And that's your determinant. Let's give one a shot. All right, so my first step is to rewrite the first 2 columns. So I put my 3, 3, -1, and then I'm going to put my 4, 5, 4. Now I'm going to work on my diagonals, and I'm going to go down 3 times 5 times 1. You know what I'm going to do? I'm going to go do a highlighter on this. This may or may not be good, but 3 times 5 times 1. Okay, that's 15. 4 times 0 times -1. Heck, if there's a 0, don't overthink it. Don't accidentally put a 4 or a -4. It's just 0. You're multiplying by a 0. -2 times 3, that's -6 times 4, that's -24. And then what we're going to do is we're going to add these numbers up. And when they add up, I get a negative, looks like a -9. Now let's do the same thing going up. So multiply upward. So that's going to end up being a positive 10. Times 0 in there, it's going to be a 0. And then here I get 12. When I multiply those, when I add those all up, I get a 22. And then you always do the bottom minus the top. So it's going to be -9 minus 22. And I'm going to end up with a -31 for my determinant on that one. Okay, now I want you to give this next one a shot on your own. Go ahead and complete it. Go ahead and pause the video. And then when you have it done, come back. All right, I got a -46. If you also got a -46, then go ahead and move on and go to the next slide. If you didn't, pause the video, figure out where you went wrong. Okay, so the process of finding a determinant really is pretty quick and easy. So that's why we actually use it to for a variety of reasons. So this first one I'm going to go to is called Cramer's rule. And this was a standard thing to learn when I went to school as a method of solving a system of equations. Because right now we know that we can do elimination, we can do substitution, we could even graph it if we wanted. But this is actually a fourth way to solve a system of equations. And to do Cramer's rule, you have your two systems here. They're in standard form. A and B are your coefficients. C and D are your coefficients here. E and F are your constants in those equations. Now, the idea to use a determinant says replace the variable coefficients with the constants. Okay, so for my X matrix, and this is doing the top, the numerator, because you can see this is going to end up being a fraction. So to figure out the X value, when I solve this system, this is what my X value will be. It will be the determinant of, and you can see here, we're using the coefficient matrix, these four. But it says replace the variable coefficients with the constants. So since I'm looking for X, I am not going to put in A and C. I'm going to put in E and F for those. So now you can see I've got an EF, and then I still have my BD. But when I'm looking for Y, I'm going to replace the variable coefficients, the matching variable coefficient, with the constants. So since I'm looking for Y, I'm not going to be using B and D. I'm going to replace B and D with the constants, E and F. So when you look at this matrix, you can see it goes A, C, E, F, right there. Okie doke. So that's what your numerators are, replacing the variable coefficients with your constants. But then to get your denominator piece, look that these are both identical. And it's ultimately just the determinant of the coefficient matrix, which is this part right here. So it goes A, C, B, D on both of these. Okay, now these are 2 by 2s. So those are the quick hitters on solving, of finding your determinant. But it also would work on a 3 variable system, which we know those take a little bit of time. Now, this does only work, remember I said earlier, if your determinant is 0, that can be restrictive. If you get a determinant of 0 in your denominator, so if somehow this coefficient matrix gave you a determinant of 0, you would not be able to use Cramer's rule. That doesn't mean it's undefined or there's no solution or anything like that. It just means you can't use Cramer's rule to solve. Okay, so let's try using Cramer's rule on an actual system. So here is my 2 variable system of equations. I got a 4x minus 2y equals 10, and these need to be in standard form. They are. And so you can see right here is my coefficient matrix. Here are my 2 constants. And so what I'm going to do to determine, I'm going to start off and I'm just going to find all the determinants that I need. And then I'll go do the little formula for Cramer's rule. So we call the determinant D is the determinant of the coefficient matrix. Now, I'm taking notes here, so I'm doing this so that you can come back and redo it. So it probably would help if you go ahead and show a little bit of work here. I am using the coefficient matrix here. And so remember what our trick to this was on the 2 by 2. You just go this way minus this way. So if I do that, if I go down, now I'm going to run out of room working horizontally, so I'm going to come down below. If I do my diagonal towards the bottom right, then I get negative 20 minus, now I go upward, that's a negative 6. So it's minus negative 6. So I'm going to end up with a negative 14 for that value there. All right, so now to find the determinant of the X matrix, we call it D sub X. And the X matrix, that means that we're going to get rid of the X coefficients, get rid of the 4 and the 3, and replace them with the 10 and the 11. So then your matrix is going to look like this. You're going to have your 10 and 11 here. Then you're going to have your negative 2 and your negative 5. And now you're going to do your determinant, because notice the bars that I'm drawing. That means the determinant. I didn't put brackets. So if I go downward, I get a negative 50. If I go upward, I get a negative 22. So it's going to turn into plus plus, a 22, and that's going to end up getting me a negative 28. Okay, let's try the determinant of the Y matrix. That means get rid of the Y coefficients and replace them with the constants, 10 and 11. Okay, if I go down, I get 44. Subtract, going up, I get 30. And 44 minus 30 is just 14. Okay, so now what we're going to do is use Cramer's rule. I have it written down here. The determinant of the X matrix, that's your middle one. That is a negative 28. Remember, it was going to be a fraction over the basic determinant of the coefficient matrix. That's a negative 14. That's going to be the X value. Now let's do the Y value. So I'm going to take my dy, which is 14, put it over my d, which is negative 14, and then this all simplifies to a positive 2, negative 1. And that is the solution to your system. Okay, now, here's the thing. I get it. I could have solved that with elimination in a third of the time that I just spent there. However, the thing is, this is the first time I've done it, so I went really slow. We get pretty fast at being able to do this mental math here, or just quickly typing in my calculator, negative 20 minus a negative 6. And I don't have to, and to be honest, probably, I did this for your notes, right? But really, I probably wouldn't even have to rewrite that. I could just see the matrix happening right here and know it's at 4 times negative 5 minus a 3 times negative 2. So I don't really have to rewrite this. So there are faster ways of doing it. The other reason that it works really nice is if your answer was some crazy, ugly fraction, you tend to battle through solving the system with elimination or substitution when you have fractions. Now, we're usually pretty nice to you and we don't give you like terrible, ugly fractions, but I'm not sure that that's reality. I mean, numbers in real life don't really play nice. And so if you were to have some ugly fractions in your answer, it wouldn't really matter because you wouldn't really have to battle them. You would just simply be writing them right here. You would write this over this, and it's an ugly fraction. So what? It's there. So it does have a purpose. So don't revert back to elimination and substitution. Give it a shot and practice trying to use that Cramer's rule. All right, so the real test is doing a 3 by 3, which we know takes a long time to do. So here's another method. It's the first time I'm doing it, so it's not going to be super fast here either, but bear with me. What we're going to do is we're going to find the determinant using Cramer's rule. So D, remember, is going to be just all the coefficients. And then you're going to rewrite the first two columns. Now, hopefully you're looking at a set of notes where I have spread this out and made it a 2-page problem instead of thinking you're going to cram this all in on 1 page. I've spread it out. We'll see. Maybe you have that, maybe you don't. Okay, so here we go. Now I'm going to go down, down, down. So we go down, down, down. So I'm going to have a 0, 6, and 24. That's going to add up to a 30. All right, now let's go up, up, up. 0, 4, 16. Add those up and I get a 17. So I'm going to end up with a negative, 30 minus, gosh, I couldn't even read that. It was so faint. Sorry, guys. So that was a 0, that was a positive 4, and then that was a 16. Add that, that's 20. So I get a 30 minus 20. All right, that value is going to be a 10. Now remember that for later. Let's go ahead and move on to the X matrix. So what that means is get rid of the X coefficients and replace them with constants. So I'm going to put in, instead of those X, I'm going to put in 1, 0, 2. Then I'm back to using my coefficients for the Y and for the Z. We're doing the determinant. Remember that you have to repeat the first two columns. I like all these zeros. I have a feeling that's going to make my life easier, and that does. So keep that in mind. That's one of the bonuses if you end up with a lot of zeros. All right, so I'm going to go down, down, down. Add those up and get 16. I'm going to go up. Oh, I did it, didn't I? I did it. Did you catch it? I said, oh, there's all these zeros. And then I got to thinking, hang on, right here. See how I did this right here and called it a 12 and forgot the fact that that's a 0? It's so easy to do. Don't do that. Okay, now I'm going to go up. That's a 0. Up is a negative 4, and up is another 0. So that ends up being negative 4. And then I take bottom minus top. So 4 minus negative 4 is going to be an 8. All right, so let's keep going. Now I'm going to find the determinant on the Y matrix. That means leave the X coefficients in there, but on the Y coefficients, you're going to put your constants, 1, 0, 2. Then back to the Z coefficients, put in the bars, repeat the first two columns. I promise you'll get fast at this. So now we're going to go down, that's 0. Down, that's 3. Down, that's negative 12. Add that all up, and you get negative 9. Okay, now let's go up. That's a 0. Up, that's a negative 2. Up, that's a 9. Oh, sorry, that's an 8. Add that up, and you get a 6. Take the bottom minus the top. So I end up with a negative 15 for the dy. That's going to go right here, negative 15. Okay, last one is the z. So negative 1, 2, 3 stays put. 2, 0, negative 4 stays put. But the z coefficients are going to get replaced with the constants. Let's repeat the first two columns. Lots of zeros here. All right, if I go down, I get a 0. Go down, get a 0. Go down, I get a negative 8. Go up, I get a 0. Go up, I get a 0. Go up, and I get an 8. And I end up with a negative 8 minus 8. So that's a negative 16 for the Z matrix, and that's going to go right here. So here's what your solution is. I guess it's kind of nice that I wrote it like that. I just put the numbers there, and now I'm just going to reduce. 8/10 would reduce to a 4/5. Negative 15/10 is going to reduce to a negative 3/2. So look at all these fractions that I would have been battling. The next one is going to be a negative 8/5. Does not come out very pretty. So I'm glad I used Cramer's rule on that one. Okay, so here's another handy use for a determinant of a triangle. You can actually find the area of a triangle with a determinant. So the trick is that the triangle in question would be like something that you would be graphing, and you would know the coordinates of its vertices. So if you can imagine its vertices, x and y, here's another x and y, and here's another x and y. And so what you do is you line up those points. It does not matter which one goes first, second, or third. You're just putting in each point in here, line them up, add a column of ones, and that gets you this 3 by 3. Notice the bars, that tells you to do the determinant of the 3 by 3 matrix. So you're going to do the determinant, do all that business, up, up, up. Okay, got it. And then you're going to take half of it. Now, this plus or minus isn't really like you think of a plus or minus. It really means it's either plus or it's minus, whatever you need it to be, so that the determinant will end up being positive, and thus your area is positive. Okay, so let's give one a shot here. I have the 3 vertices given to me, so I'm going to go with area equals. I'm going to write a 1/2. It's a plus or minus. I usually just adjust it and make sure it's positive in the end. So my first coordinate is 1, 0. And I have a 2, 2. Again, the order you do this doesn't matter. Column of ones. All right, let's find the determinant, and then we're going to take half of it. All right, to do the determinant, I rewrite the first 2 columns. Okay, then I'm going to go down. That's a 2. That's a 0. And that's a 6. That adds up to an 8. Okay, let's go up. There's an 8. Here's a 3. And there's a 0. So that would add up to an 11. And 8 minus 11 is -3. Now I'm going to take it times, since it's already negative, looks like I need to take it times a -1/2. So the area of this is positive 3/2. That's a pretty small area. That's a 1.5. All right, so this truly is a handy way to find the area of a triangle, because this wouldn't have been very pretty necessarily to try to use one of our other formulas. We probably could have done Heron's formula, but you would have had to find the distance between 2 points to get that, and then distance between 2 points and distance between 2 points. So that is an option, but man, that's going to take a long time, and the determinant's pretty fast. Not only can you find the area of a triangle, but you can also test for collinearity. So if I gave you 3 points and I wanted to know if those 3 points were collinear, that means they line up. Well, those 3 points are still like in your mind, if you can imagine them creating this triangle. So I'm going to take those ordered pairs that they're giving me, the 3 points, and I'm going to put them in my matrix the same way here. And I'm really going to find the area of the triangle they create. But if you think about it, these 3 points, if they all line up, then what would the area of the triangle they are creating be? So hopefully you can imagine that if I'm testing if these points all line up perfectly, well, I couldn't really draw a triangle. Like I'm going to draw a triangle to there, to there, to there. And I'm really just trying to exaggerate that a little bit. There is no triangle there. So if these are truly going to be collinear to where you can't draw a triangle, then what do you think the area of the triangle would be? All right, hopefully you think that the area would equal 0, because it doesn't really create any area inside of it. So its area would be 0, which means those points would have to line up perfectly. So let's practice one. Doesn't look like I gave myself any ordered pairs, so I'm just going to make some up. Let's say you have let's say you have a 4, 2, and a -1, 3. And let me think here. Let's do a 7, -2. And I want to know if those points line up perfectly. I'm going to set this up. I'm going to do my plus or minus. Keep moving the board, sorry. A plus or minus 1/2. We'll see how that plays out. And then I'm going to put my coefficient or my ordered pairs. So it's a 4, 12, and it's going to finish with a 1. I have a -1, 3. It's going to finish with a 1. I have a 7, -2, and 1. All right. Repeat the first 2 columns. And let's do our testing diagonals here. If I go down, that's a 12, an 84, and a 2. 12, 84, 2. All right, so what would that be? That'd be 6. I think we're at 98 there when we add those up. Okay, so you have your 98. Now let's go up, up, up. So I'm going to have a 21, -8, -12. So when I add those up, I'm going to end up with, let's see, that's a -20. I'm going to end up with just a 1 right there. Okay, so now I'm going to take bottom minus top. So 98 minus 1 equals 97. And then that's the determinant. So now since it's already positive here, I'm going to take it times a positive 1/2. So I have a 1/2 times that determinant. That was a 97. That does not come out very nice. It's going to end up being, what, 48.5. And we are done. That is the area of that triangle. So definitely not 0. The area did not equal 0. So those points are not collinear.